Hello there and welcome to another video. Here on my workbench is one of the lights that I usually use to film these videos. These things were dirt cheap on Amazon, and I think it was about $15 per light and stand pair, and I bought them right after using a literal desk lamp on my first video. Unsurprisingly, that gave less than ideal lighting results, so I knew that I needed something to upgrade to. So why do I have it on my table, and why am I starting to take it apart? Well, these lights have been good, but I'm looking at making some new ones that'll be brighter and not USB powered, as that severely limits the amount of power that these lights are able to use. I'd like to first take a look at, and also show you guys, the construction of these lights that I've been using, just to get an idea as to where to start. As you can see, the lights are really simple, and they just have a bunch of small LED chips soldered to the PCB that's actually made out of aluminum. Yeah, these lights use an aluminum PCB, and there's a really good reason for that. The aluminum PCB pulls heat away from the LED chips and distributes it and dissipates it in a way that a regular FR4 PCB cannot. So, with a little bit of background on aluminum PCBs and what they do, I was quite happy to see that the sponsor of today's video, PCBWay, offers aluminum PCB manufacturing. PCBWay offers a bunch of manufacturing services, not limited to just PCBs as their name suggests. They offer 3D printing, CNC machining, and even more. But today I'm going to be trying out their aluminum PCB manufacturing service so that I can build some LED filming lights of my own. I hope to make these more powerful and brighter, while hopefully also keeping them around the same size as my old ones, and the thermally conductive aluminum PCBs from PCBWay should allow me to do this. The PCBs are nicely cut without any super sharp edges, which is really nice. I think that the white solder mask also looks really nice on them, and it might even help with the LEDs by reflecting any light that spills onto it back outwards and towards whatever I'm trying to shine a light on. Now, as for LED chips, I went with some really inexpensive ones that I bought from Amazon. They're in the 1210 SMD package, which I chose because it should offer a nice balance between ease of soldering and LED module density on the circuit board. I've never really soldered many SMD components before, so I'll be interested to see how this goes. I first had to figure out what terminal of the LED was negative, because one side of the LED is marked with a little triangle in the corner, almost like a CPU. It turns out that that side of the LED chip is the negative terminal, and based on that, I can make sure that I don't solder any of these LEDs on backwards. I started trying to solder one of the LEDs to the board, but this is when I ended up running into one of the challenges with an aluminum PCB, and that challenge is that they're highly thermally conductive. But wait, I thought that was the thing that made them so great. Well, yes, it is, but there is a downside when you're soldering the components to them for the first time, because it wants to eat all of the heat from your soldering iron, which makes it really difficult to solder to. Now, I didn't record any of the soldering process because I needed to be able to focus fully on getting the soldering part right and not end up being distracted by trying to film it, and it also took about 2 hours to build this light, so I definitely didn't want to do the whole thing while leaning around my tripod. I'm about to show you the end product, but if you're someone who's allergic to imperfect soldering joints, I'd avert your eyes for this part. In the end, the solder joints surely aren't pretty, but for a first attempt at soldering a bunch of SMD components, I think I'll give myself a little credit because all the LEDs work and I only destroyed about 5 of the 160-ish LED chips that this board demands while soldering it. Also, to make my soldering job far easier than it seemed like it would originally be, I determined that I needed a board heater of some sort. This would stop the aluminum PCB from eating as much heat from the soldering iron as it would at room temperature, but there was one issue. I don't have a board heater. Some of you looking at doing this are probably in the same boat as I was here, and I have some good news for all of us. You can build a makeshift board heater with a couple power resistors and a perf board or two. Here you can see the one that I created. It's not pretty and the power resistors certainly aren't happy with how hot they were running, but it did its job beautifully and made soldering on this PCB super easy compared to what it was before. And just a little side note, if you're thinking about building one of these little board heaters, be careful with it because it puts out a lot of heat in all directions. So make sure you shield your table and watch the thing carefully so that it doesn't risk starting a fire. In any case, look at how absurdly bright this thing is. That's a lot of light for one of these boards to be putting out, and I plan to use 3 of them, so this workplace is going to be brighter than the sun. Here, take a look at how one of my old lights compares to the new light I've just built. Let's do that once more. Old, and then the new. Massive difference, right? Okay, maybe not, but that's because I'm messing with you. That's with the old light at maximum power and the new one not even close to maximum power. How about we do a full power test with both of the lights, shall we? Here's the old light. And here's the new light. Now that's a truly massive difference. Notably, the color in the new ones is a little different than the old ones, so I'm gonna have to take a while and get my white balance reset with these new lights, but hopefully that doesn't prove to be too much a challenge. Sweet, so the light works and is far better than my old one, and I can tell you, that aluminum PCB is working to keep it cool at max power. But there is one issue, and that issue is that at max power, about 35 watts, the aluminum PCB can't quite keep up on its own. Now this isn't a surprise to me, 35 watts is a lot of power and certainly a lot of it gets turned into light, but there's also not an insignificant amount of that power that gets converted into heat, and that's far too much heat for a small piece of aluminum to deal with all by itself. I knew this would be the case originally, and you've probably noticed the two holes in the middle of the light's PCB at this point. These holes are so that I can put screws through them and mount a heatsink to the back of the aluminum PCB. This will allow the aluminum PCB to work to wick heat away from the LED chips themselves, and then the heat will be transferred into a beefier heatsink which dissipates it into the air far more effectively at this level of power. Now that I've mounted the heatsink to the light with a bit of thermal paste to aid in the heat transfer, the light unit itself should be good to go. The only thing it needs now is a nice connector on the end of its lead so that I can connect it to a power distribution hub. I bought a bunch of these JST RCY 2-pin connectors, which are commonly found with medium-small size LiPo batteries in drones and RC cars. These little guys are rated for 3 amps, so they should be good in this application. I don't have the proper crimp tool for them, but that won't be stopping me. With a connector soldered to the end of the lead that connects to the light, I made a short, maybe 3-inch long wire with the mating connector on one end of it. I then repeated this 2 more times so that I had 2 leads for 2 more lights and 2 more short connector wire pairs that mate with the light leads. I'll be connecting the 2 other light leads that I made to the 2 other lights that I plan to build once the LED chips for them arrive. I only bought enough chips originally to make and test 1 light to ensure that my design was good before I went all in. Lastly, I took all 3 short wires and soldered them all in parallel on a small piece of perf board. I'll connect my bench power supply to this piece of perf board so that I can distribute power to all 3 of the lights for the time being. It's not a very elegant part of the project, but I'm hoping to make a nice hub for all 3 lights with per light high frequency PWM dimmers that's powered by an external dedicated power brick in the near future. Stay tuned to see if that happens. Off camera, I added a capacitor across positive and negative of the power distribution board because when adjusting the voltage on my analog bench power supply that I plan to use to power these, the voltage can get a little jumpy when turning the pretty cheap potentiometer. There is a decent chance that there are some voltage spikes a bit over what these LEDs should be receiving coming out of that power supply when I change the voltage, so I put this capacitor in the circuit to hopefully suppress those spikes and protect the LEDs somewhat. And hey, would you look at that? We're nearly done with this cool little project. There's one more major piece that needs to be done for this light though. That is the creation of a mount that allows me to put it on one of the stands that I've been using for my lights this whole time. These stands have been surprisingly durable, so I'll get as much use as I can from them before I throw them out eventually. This means that this PCB needs to connect to a 1/4" 20 thread, which is just the standard camera and tripod thread. After a little while spent in Fusion 360 and a few iterations to get the dimensions just right with my cheap 3D printer's tolerances, I had a nice little mount that screws onto the stand perfectly. Yes, it does screw into plastic threads which aren't very durable, but I leave my lights attached to the stands all the time so they shouldn't wear out from excessive screwing and unscrewing. And hey, if they do give up eventually, I throw another mount on the printer and I'm back up and running in 30 or so minutes. Let's fast forward through a few days and 4 hours of soldering, and hey, look at that, it's all the parts I need to assemble the last 2 lights magically on my workbench. You'll probably notice that one of these 2 lights is getting a much larger heatsink than the other 2, and that is because this is the light that I keep permanently mounted above my workstation, right above and behind the monitor in my setup. I use this light when I'm working on regular projects, and when I'm doing that I don't have my other 2 lights up. So I'll probably run it much closer to maximum power, and the larger heatsink will help it stay cooler for longer at these higher powers, so that's the main reason I chose it. And with that, all 3 lights are done. I'll do a comparison with the fully lit old setup and the fully lit new one, but firstly I'd like to thank PCBWay once more for providing their aluminum PCB manufacturing services for this project. Without these aluminum PCBs, I can say with confidence that these LED chips would overheat very quickly and these lights wouldn't work at all. The thermal conductivity of aluminum PCB technology is awesome, and having a place that can manufacture them with great quality at reasonable prices is quite frankly incredible. Though if I was to do this again, I'd probably use their PCB assembly services as well as their PCB manufacturing services so that I don't have to manually solder about 500 SMD LEDs. Alright, let's do the final comparison. Here's the setup lit with all 3 of my old lights at max power. Now, keeping the same camera exposure settings, I'll move over to the 3 new lights at max power, and holy smokes is that ever an upgrade in brightness. I'm super happy with how these turned out, and now all I need is an elegant control box for them. Time to get to designing, I guess. In any case, that's all that I have for you today. Hopefully you were able to at least enjoy this video and maybe even learn a thing or two. I hope to see you next time. Goodbye.